Okay, we're recording now. So yeah, let me share my screen and we'll take a look at our website. Here we go. And just a quick reminder that I usually will go and mute everybody so that the sound is more clear. And if you have a question, you can just unmute yourself and speak up. And if there are more people that want to speak at one time, then we can use, under the participants, you can use the raise hand, or you can type your question into the chat like that, and then I can address your question. Okay, so there's several ways to ask questions during class. All right, so we're looking at the website. You should see this when you start. So tonight that essay is due. Just quick answers, just the ideas. Don't worry, don't stress about it. There's 3 different questions. You have to ask the first one and submit it, and then the second one and submit it. Okay, and then there's the syllabus quiz. I have that set all the way at Sunday, but it's good to get that one done. Those are just participation, so it's not a huge portion of the grade. It's the participation category. And then tomorrow, oh, I see. Okay, tomorrow you're gonna see another quiz option pop up down here. Maybe I'll go and show what it looks like for me. This quiz, our quiz for tomorrow, is going to show up down here, quiz. Oh, let's see. There we go. It'll look like this. So the first one tells you what's in the quiz, and the second one is the quiz itself. So it'll look a little different, but you'll still have that link, and that will pop you into the quiz. Is there a pre-lab due Monday? Yes. Yes, there's a pre-lab due Monday. I need to get that programmed in. I'm going to try and make it work just like the quiz. I mean, not exactly the same kind of questions, but have it on WAMAP so you'll find it the same way. When you click on Monday, the pre-lab assignment will hopefully be down there. Okay, let's see. So let me go back to student view. Okay. Oh, interesting. I'm getting a little bit of feedback in the sound. Oh, I see. There was another message, another box. Okay, so I'm going to go inside the course resources. And I'm going to go to the class worksheets. Now, if you are new in the class, please scroll all the way down to the syllabus, text, and periodic tables. This is the link to the website where you can find our free online textbook. So there's that. Maybe I should make a pinned post with those. Here is the syllabus. Here's the syllabus addendum, which has campus services such as the disability process and the email address for that. And yes, Linda, I'll get to that in a sec, thanks. What else? The periodic table. This periodic table is the one that I advise that you print and use, maybe 2 copies. And it looks like this. So this is the one that you can use on quizzes. I'd like you to have one that is blank to use on exams and quizzes, and one that you print out to use during your work that you make notes on, okay? All right, so I'm still doing a little bit of a review of how you navigate the website for people who may have questions or are just now joining the class on the wait list. So I'm going to go into the class worksheets, number 1, matter, and I'm going to pick up where we left off. I also wanted to mention, so I'm going to close that back up and click over to here. Physical and chemical changes. We left with this diagram. Okay. So there are a couple of things about this class. Normally at this point in the in-person, we would have done a lot of stuff to build our community and learn each other's names. And many of our activities take longer online. Make sure everybody's on board. And there are a lot of questions. So things like, let's see, I wasn't able to get access to Alex. And so if you have questions, please try to log in early. I'm going to try and open the meeting a little bit early. I don't usually like a lot of questions before class, but that is a good time to make sure that you can get in and participate in the class. So I'm going to start trying to open it up. I usually aim for 5 minutes early. If you have additional help needs, you can message me and let me know, and I can open it up 10 minutes early or more to make sure that we can address your questions. So if you're having trouble, please try to get into the meeting early so that we're not already starting and going, 15 minutes into questions to help everybody get on board. So message me in WAMAP. It's the best way to reach me quickly. And then the other thing is let's try and wrap up our various questions by 9 o'clock so that we can start with content and then keep on top. All right, there were some other questions here. Let me go back to WAMAP. I'm going to go to the instructor view so you can see what I'm looking at. Now I'm going to click on Friday. You see how the day turns pink. Then right below here, gray means that you can't see it yet. But this is going to open at 9 a.m. and it's going to close at 10 a.m. So we have that 1 hour window. We're going to meet here and talk about content we're going to review before the quiz. So I will plan to let you do the quiz in class time at, let's see, that's 15 minutes. So that would be normally 9:35 is when I'd say, okay, go ahead and open up the quiz and begin your work. And that would give you 15 minutes to do the quiz. Now, if you have trouble getting it open, you should be able to open it up until 10, and we'll still be online together. So we should be able to answer your questions and make sure everyone is able to start. It's a 15-minute quiz. There's a grace period, so it's not going to kick you out after 15 minutes, but it will delay your score and show an overtime warning that I have to click through. I believe at 20 minutes, it might kick you out. So there's some changes to WAMAP, and I'm not sure how everything works. So still a learning curve there. It shouldn't take you 15 minutes. It'll be pretty quick. Now, if you have a time extension, that will be programmed into WAMAP already. So I think the important thing is that you open the quiz before 10 a.m. If you are not able to do that, then message me inside WAMAP so we can solve that problem. Okay, I think that wraps up all of our questions. The pre-lab will be due Monday. The pre-lab will be due probably at 9, probably before class starts. So good to be reading that ahead. And what do we have for the intro? Just the pre-lab will be due, and then you'll have the post-lab assignment as well. Okay. Any further questions on organization? So I'm going to hop back over to the worksheets. And we were talking about physical and chemical changes. For all of these transitions, there are, here we go. Bring in my toolbar over here. One more question about lab. How do we prepare for lab? Read the lab manual. It's posted. Okay, let's take a moment to do that. Oh, I have to go to my mouse tool. So if you click on Monday, the lab, right down here is the link. You could also access it by going into this, let me close that, by going into this section where all the labs are listed, but you can also click here and it'll just jump to that place. So the lab manual pages are linked down here. There's a lot of reading for the introduction, and this is what we did in our first lab period, which was unfortunately on Monday, and then I didn't get the record button clicked. I wonder if I did and it's in there. I didn't find a recording for that, unfortunately, and I apologize. But you'll read this document and follow the syllabus notes. The syllabus describes how to prepare a notebook. And then also read this information, right? We'll have that pre-lab exercise. You can work that on paper, and then I will port that into WAMAP. There may be a point at which those questions will not be identical, that you may get randomized variables so that every student has a different question. So I don't know that I'll get that done by Monday, but you can work the exercise in the pre-lab, in the lab manual, and that will prepare you for the online pre-lab quiz, essentially. Okay? All right. Any more other questions? All right, so we were talking about physical and chemical changes and the names for those. So we know that when we have a liquid and we turn it into a solid, that's freezing, like freezing ice cubes. But these ones too, going directly from a gas to a solid, is called deposition. That is right here, deposition. And the opposite of that is sublimation. So sublimation is, and I don't really like this red. Let's go back to blue. There we go. So going from the solid to the gas directly, or the gas to the solid directly, that has a name, sublimation and deposition. Anything that happens on this diagram here, these are physical changes because you can recover the original substance. You don't destroy anything. All right. So chemical changes, such as this picture, we have 2 hydrogen molecules and 1 oxygen molecule. Those gases are completely obliterated and used up. They are rearranged to form 2 water molecules. So this is a chemical reaction. It completely destroys your sample and forms new substances. Evidence for chemical reactions usually involve bubbles. So we might talk about why is that bubbles? Bubbles could be physical or chemical, right? Can you think of an example when bubbles are physical change?
Boiling water.
Yeah. If it was boiling, then that would be on that axis, liquid to gas. Why is this chemical and not boiling water? We have to look at some context clues. What do you see there?
There's no heat being added to it.
Yeah, there's no heat added. What else? The bubbles are coming. Oh, go ahead.
Oh, sorry, go ahead.
Oh no, I love to have you guys participate.
Is there something being poured inside?
In the second diagram, we see it being poured, but what's happening with this one?
This one, it looks like freezing. I mean, it's bubbling, like soap bubbling, looks like, you know.
Is that a straw?
No, it's a piece of metal.
Oh.
It's just a piece of metal that they dipped into the water here, and it's making bubbles. I see the bubbles are coming off of the metal. They're not coming off the bottom, and there's no burner here. I don't see any heat. When we boil water, the bubbles are pretty even, or they come from the middle where the heat is. In this case, the bubbles are coming right off of the metal. So yes, go ahead.
If it is group 1, it's gonna show us bubble while we insert it in the water.
Group 2. Group 1 is flames.
Okay.
Yeah, and you don't have to know that. But sometimes, like the Mythbusters, they would use sodium, a group 1, to try and explode a toilet. Did you see that? I don't know. I used to link to it, but then they don't let us anymore. They don't let us show that.
Is it butter because we as the water hit the metal, then that water bounce back and make some pressure, and then therefore make a bubble, and therefore also a physical change. Because if I take out the stick of the metal, then the water will return to itself after it's settled down. Is that the case?
No, this is a chemical change.
Oh, it's
And we do see a new gas formed. And that's why it's chemical change. So the solid metal is chemically dissolving, and when that reaction happens, it releases bubbles. So if you remember on the lecture, I showed the example with nickel inside HCl, and the nickel dissolved into the green solution and hydrogen gas bubbled off. So when we see bubbles, a lot of times that means a new substance is formed. So this one is a chemical, right? New gas formed. Now this one is also, these are all chemical changes. This one is also chemical. This is yellow and colorless. I'm sorry, yellow and clear. And this one you can see it was clear, but no color. And where they join together, it's opaque, it's solid now. As each particle connects, it's forming tiny particles of solid. This is a new solid forming, right? Precipitation can mean a new solid forms. And then oxidation, the flame, that's releasing heat and light. So those are the three ways we know that a chemical reaction has happened. We see a new substance form that's either a solid or a gas, or we see heat absorbed or released, something like that. All right. So we talked a lot at the beginning about classifying matter, pure substances, mixtures. And so here's just a quick review. We could have, if we had saltwater mixture, we could recover the pure substances, the salt and the water separately. And that would be a physical change such as the distillation. For the salt, we know that's a compound, so it can be broken down into its elements. And that would be a chemical change. So that electric current causes a chemical change there. The water could also be broken down into smaller substances, the elements that form the water. So these are compounds and these are the elements. Once we have elements, we cannot break them down by chemical processes. Okay, so compounds can be broken down into elements using a chemical change. Here are some images of some pure substances, some elements. This is sodium, it's soft and shiny. And here's barium. It's got that dark color. It's also a crystal lattice, right? So those are elements. Hydrogen and oxygen are also elements. They are molecular elements. Chlorine has a color. Hydrogen chloride is the gas form of hydrochloric acid. Water is very familiar. Here's sodium chloride, that's table salt. And then here's barium chloride, which would be toxic, but it looks very similar. White crystals, and this has a slightly different structure. So when we look at table salt, we can classify it now just one answer. It's an element, compound, a homogeneous mixture, or a heterogeneous mixture. Okay, so maybe you can take a minute and pick one of each of those. If you're not sure, you can scroll back up. If you're following on your own notes, you can scroll back up and look at the pictures again. So table salt, what is table salt? Right, salt is a compound, yeah?
Yes.
What about sugar?
Also a compound.
Also a compound, yes. Thank you. All right, what about air? What's air?
Element.
Element.
It's got two different elements.
Mixture of compound.
Is it? Yeah, it's a mixture.
Yeah.
It's got two different elements, but they're not connected together. So for air, it's got, oh, let me go back to my little spot.
Nitrogenous.
It's got 4 of the nitrogen and 1 of the oxygen. So they're not compounds because they're not connected together. These
It's
are,
a
it's a mixed,
Mixture.
yeah.
Homogeneous or heterogeneous?
Yeah?
So it's
What kind of mixture?
Hetero.
What do you think from this picture?
seems like it's heterogeneous. Isn't it?
I think homogeneous.
Did you say homogeneous?
Yes.
Yeah. So let's think about a minute, like think about air, which is only 20% oxygen. We really rely on the air to be evenly mixed because it could happen. It just doesn't happen very often. But what if, just consider if all of the oxygen suddenly went up to this corner. So 20% of the room had oxygen and it was all in the corner. Then I would not have any oxygen to breathe, right? So all gases, if you think about that, that's one way to remember. Any gas always mixes completely evenly. So it will be homogeneous. Oh.
Hey, I have a question.
Uh-huh.
So like on the top right, the first part is a homogeneous mixture, you said, and the second one is the ocean.
Yeah, this is showing it's coming from the air up here. So yeah, that's a homogeneous mixture. And then down here, this is coming from the ocean. Is that homogeneous or heterogeneous?
It looks wait, like as in compounds or elements?
No, it's a mixture.
Yeah, okay, so salt water. We're looking at salt water. When you pour some salt in some water, what happens? Do you taste the pure water and then at the end you get to the salt?
No, it'll be dissolved, so you probably taste a mixture of it.
Yeah, you taste that mixture and that means it is homogeneous.
I have another question.
Okay, yeah.
So what if there's pollution? Isn't it a reaction from burning or fuel of something?
There could be
And
pollution in the atmosphere, yeah. So those gases will also be evenly mixed usually. Now, when we talk about the actual weather, sometimes there's different layers of the atmosphere, but in our immediate area, it's going to be evenly mixed.
oh, okay, cool.
They tend to go towards an even mixing. So when you cough out your coronavirus, right, it starts in one place and then it spreads out and gets evenly mixed.
Oh, okay.
So because it's a gas, the gases will try to evenly mix. Actually, the virus is not a gas. It's just carried on particles in the breath. But anyway, same idea though.
Okay.
Okay, now the next one. We're looking at these molecular level diagrams, and we're going to try and label each one as an element, compound, or mixture, and a solid, liquid, or gas. So these are showing everything spread out. This is sitting down at the bottom, and it has a very ordered array. This one, I don't know if you can see my mouse. Let me get my little spot. This one is showing like a jumbly mix. Okay, so like it's moving. And then this one is also showing an array. Okay, so take a minute and consider those. Okay, does anybody get different answers? The hard one, I think, is this one. Why is it a mixture and not a compound? So if it was a compound, it would have a fixed proportion? Does it have a fixed proportion? No, it doesn't, because over here, it's got a bunch of gray atoms and then just one clear one, one white one. Here it's got two white ones. So that's a mixture. It has variable proportions. Now let's take a look at these. Which ones are chemical or physical changes? So if it's a chemical, we'll put a C, and if it's a physical, we'll put a P.
Oh, can we go back like I say the mixture, but you put the B compound and mixture. So the C.
Oh.
Yeah.
Thank you. Here we go. Did that fix it up? C was a mixture, right?
Yes.
Okay, thank you. Thank you. I just put it in the wrong place. All right, so burning, somebody said chemical. Yeah, combustion, catching on fire is going to destroy the original sample and turn everything into carbon dioxide and water. Condensing. So on this, we'll think of our axis. Right, so condensing is when it goes from gas to a liquid. Yeah. What about dissolving? That's a physical change, and that we might say is aqueous. When something dissolves. So we'll talk more about that. Rusting is another chemical oxidation. Vaporizing. Vaporizing is going from a liquid to a gas. And then precipitating. That's typically forming a new substance. So I would say chemical. If you have background in chemistry, you might say, we could have a supersaturated solution and then we'd have a physical precipitation. It could happen. But here we'll think of it as forming that new solid, because that's what we talked about already. Okay, cool. Now, if you have made some annotations, if you went to View Options and clicked Annotate, then there's a little button that says Save. If you want to save the screenshot, you can do that. So that's always available to you. It's not my preferred method because then you have a million screenshots and it's just too much to handle for me. But I'm going to go ahead and clear these. So if you wanted to save it, click Save Now. All right. Now we also talked about chemical elements and their symbols. We talked a little bit about lead and gold. And here's a good rule of thumb. No up to number 20 on the periodic table. So that means on our periodic table, up to calcium right here. So those you should know. And at the end of the worksheets, I will add more. So I'm not going to give you a long list of names to memorize, but I want you to get familiar, to get comfortable with them. So one way to do that is to find the printable periodic table and begin looking at that. Okay. So we'll be using these and we need to understand our chemical formula. So we have 2 H's and 1 O in water. What about sodium carbonate? How many sodium?
2.
Yeah. And how many carbon?
1.
That's right. And then how many oxygen?
3.
3. Yeah. All right. Now, if we have parentheses here, we have to distribute that 2 to everything inside it. So this would have 3 barium, 2 phosphorus, and 8 oxygen. So go ahead and fill in the numbers down here. Nice. That looks great. I'm so excited that you're annotating. That looks great. I don't have a way to show who's doing it, but I really appreciate it. Okay, so we have 7 carbon, 5 hydrogen.
It's me.
All right, good job. I think several people have been helping, so that's great because I see we have 2 6s. All right, so 5 hydrogens, and then we have 3 nitrogens. We had to distribute that, and 6 oxygens. Okay. All right, now as we look at the periodic tables, oh, we did this. We did go over this. Great. Each column up and down is called a group or a family. And each row is called a period or a series or sometimes a shell, like the outer shell. The main group elements are the ones with the tall blocks. And then we have group 1 and 2, alkali metals, alkaline earth metals. And then on the other side, I should just get my periodic table. Over here we have the noble gases, and inside one we have the halogens. Those are all very important to know by name. Yes, transition metals. Transition metals are in this part. And the inner transition metals are right here. And they actually slide inside. They slide in right here. Oh, can you see? I can't see myself. Okay. So the LA and AC right there. All right. So these are arranged by their properties, and that makes it so that makes it easy to predict what properties something has just by where its location, where it lives on the periodic table. So what will be similar to calcium? Here's calcium. What will be similar to calcium? And I'm going to scroll this up a little bit. Oh no, it's all just other stuff. Okay. So go ahead and circle the ones that will behave similarly. Anything else? Yeah, nice job. Okay, I think that's it, just magnesium and strontium. Are there any questions? What we're looking for, here's calcium. Other things in that same column will have the same kind of behavior. Fluorine, fluorine is over here. Fluorine is a halogen, so we're looking for other halogens. And those are chlorine and bromine. Great job. Okay. I think the rest is a little bit of overview. Metals are shiny and they can be strung into wires and they conduct heat and electricity. That's metallic properties. Non-metals, here's a picture of sulfur. Sulfur is a non-metal. If I hit that with a hammer, it's just gonna shatter apart into dust. So that is a non-metal property. It is brittle. Silicon is a semi-metal, and we can change its properties a little bit, make it act more metallic or less metallic. So right along that staircase are the semi-metals. So this is nice. I like how it shows hydrogen on its own. Hydrogen is right here on the periodic table on group 1, but it's a non-metal. It's a gas, so it's not shiny or conductive. It kind of lives right here, right? So just like you see the lanthanides and actinides, they slide in right in the middle there, right inside. It's almost like the whole periodic table slid in between hydrogen and helium. So it's kind of strange that way. All right, so the purple ones are metals. Here are the semi-metals in green and the non-metals in yellow. Now you need to know some of the standard states. The standard state is room conditions. It's a nice warm room. 1 atmosphere is at sea level. So these are our standard conditions, just room temperature, sea level pressure. There's only 2 elements that are liquids, and one is bromine. We saw bromine a little bit in our examples. And the other is mercury. This is the only liquid metal. It's so crazy. Mercury is like your weird uncle, very strange element. It's also toxic. We used it to learn a lot about chemistry, but it has vapors that are toxic. So many chemists died in their discoveries. We don't see it used much anymore. So only 2 elements are liquid. All of the purple ones are solid and the yellow ones are gas. The noble gases just have 1 atom, noble gases. And then we have the diatomic 7, right? And those make that 7 shape on the periodic table. It's these ones. Maybe I should pick a different color. I don't know. Okay, here we go. And also these ones, right? There's 6, and then this one. So that makes kind of a 7 shape. So you have to know the diatomics is so important. You have to know that these always have 2 atoms together. Oh, there's the 7 shape. Good. Plus hydrogen is number 7. Okay, now here are some symbols that you need to know. It's good to know some of the transition elements, and I'm going to add a few more. I'm not going to just list these and test them on tomorrow, definitely, but just to get familiar and comfortable. So a lot of times we do talk about titanium. Oh. Titanium. And, you know, I don't know why I exclude here strontium. I'm not going to ask you a lot about it, but just to recognize what we're talking about. All right, what else? Let's talk about gold. We're going to keep gold in there. Remember, copper, silver, gold, and platinum is right next to it. What else? I think we should go ahead and keep arsenic. Sometimes I put arsenic on there. I'm going to try and get that in the right place. Okay, a little better. Arsenic, and next up is selenium. What else? Do we have lead on there? Oh, yeah, lead and tin. And I guess that's it. Got iodine. Good enough. All right, so on these things, what else could there be? I'll just talk about them. I'll write them. I just want you to be able to find it on the periodic table. Does that make sense? Zinc, cadmium. Oh, cadmium. We talk about cadmium. Let me add cadmium here because it's a special exception too. Okay. One thing that I will say, oh, spelling. I'm pretty easygoing on the spelling as long as I know what you mean. If you make a little mistake, it's okay. But if you have a word that's like halfway between one element and another, then I can't give you credit for that. So try to get the spelling right, but if it's a little bit wrong, usually that'll be fine. When WAMAP grades, it's going to be grading for spelling because it's a match grading algorithm. So I will always be looking through, and if it grades you wrong and it's close enough, I'll just give you more points. Okay, so sometimes the grades will change and I'll go through and add partial credit. All right. Here are the names, and then I wanted to acknowledge in here. In one of the sections, they talk about adding and removing electrons. And we'll come back to that later. I don't like to group that in the very first week. We'll come back to that after we do a couple more things. Okay? So we are almost at the end of our time, and I am going to stop the share and open it up for questions. So how did that go? Does anybody have questions about how we were using it? All right. I'll see you tomorrow and we'll do the quiz and answer more questions. So if you're all set, you are welcome to log out and leave the meeting now, and I will stay on to answer questions for individuals, okay? All right, see you tomorrow.